Okay, so today's topic is clustering. It's one large topic, big topic. So we'll see total two topics today. One is clustering and Snowflake micropartitions. Okay, both. Password, I think password one. Okay, so today's topic we'll see clustering and Snowflake micropartitions. We'll see both. You're able to see my screen, right? Okay. Are you able to see my screen?
Yes, we are able to see.
So it's 11:18. Maybe clustering, at least I'll try to complete this. Yeah. Okay, anyway, let's see micropartitions in Snowflake. So we know, like, whenever we are uploading the data is stored in the data storage layer, right? Here the data, all the data is stored. So data here, the data is stored in the form of micropartition. Okay. So all the data, your CSV, JSON, whatever it is, it will be saved as a micropartition inside Snowflake. So let's understand what is that micropartition. All data in Snowflake tables is automatically divided into micropartitions. All data in Snowflake tables is automatically divided into micropartitions, which are contiguous units of storage. Each micropartition contains between 50 MB and 500 MB of uncompressed data. So that means whenever you upload any data into table, in the backend it is saved as a micropartition, and each micropartition consists between 50 MB to 500 MB. Anyway, like you saw, did you see this question? I mean, if you remember.
Yes.
Yeah. Group of rows in table are mapped into individual micropartitions organized in a columnar fashion. Cloud service, yeah. So this is about micropartition. That means whenever I upload any data in the backend, it is saved as a micropartition. So let's say if I uploaded like 1 GB of data, 1 GB of data is created into multiple micropartitions. Each micropartition size could be anything. This is, I cannot control the size. Anything between 250, 100, 500 MB Snowflake will save. If it saves as a 500 MB plus 500 MB, then it is like almost like 1 GB, right? So group of rows in table are mapped into individual micropartitions organized in columnar fashion. So this is how the micropartitions will be there in the backend. Coming to, let's understand, see, to pictorially, if you want to, I mean, visualize, these are micropartitions, right hand side. In left hand side, I have a table, right? So I have this table. This is a table. In this table, I have this type column, name column, country column, date, right? So 1, 2. So here, see how many rows are there? 1, 2, 3, 4, 5, 6. See, 2 is there, right? See, 2 is there. Next one is 4 is here. 3 is here. 2 is here. Next one is 3 is here. 2 is there. Same way remaining columns ACC, see ACC, BAC, right? Same way this one country UKSPDE, DEFRSP. So that means if we upload the data into table in the backend, it will be saved in this structure. When I say micro partition, the micro partition in the backend, right? It will save something like this. So that will be saved in the storage layer. The
In the
backend, yeah,
memory.
it's the data. Yeah,
Okay. Yeah, it looks like register in the CPU as we initially studied.
but this is what how it looks like. Okay, so all your columns name, 1, 2, 3, 4 columns. 4 columns are there here. It is saved in the columnar fashion. Okay, so micro partition is not compressed. This is not compressed, but type is compressed, name is compressed, country is compressed, date is compressed. Okay, all the three, the compression is applied at the columnar level. Okay, these are compressed. Micro partition, whole micro partition is not compressed, but each column is like compressed and it will be saved. Okay, so that is anything. So see, there is a no rule like first 6 rows, it should be one micro partition. No, anything between 50 to 500 MB. If the first 2 rows is 50 MB, yeah, then here it contains only the 2 rows, 2 and 2. That's it. Remaining may, if it is like 500 MB, this could be like second micro partition. Third micro partition can contain 2 or 3 rows. So one thing we know, like each micro partition is between 550 to 500 MB, and we cannot control this. That is like Snowflake will decide. Okay, so that is about micro partition. So there is a micro partition depth. I'll come to this. Okay, now let's see. So let's run one query in Snowflake. Why we do clustering is for performance optimization. All right, how many seconds it took? Around 21 seconds if I round up. One second, guys. I'll be back in a second. But in this meantime, just take a look at this partitions and all right, I'm back. Sorry. Yeah. So if you see partitions total 68, what does it mean? So if I hover this table, how much of data is inside the table? 1 GB of data. That means 1 GB of data, uh, it is saved as a total 68 partitions. Total 68 partitions. Okay. 1 GB of data is divided into 68 partitions in the backend. So when I ran the query, it scanned all the partitions. I got the data. Now what I'll do, let's say I'm working for some team and I wrote this query where market segment is equal to building. Market segment is equal to building. See, let's turn off that. Yeah, anyway, let it be. How many partitions it scanned? 68. See, usually, guys, we'll do clustering on table which is greater than 1 terabyte. So if I do the clustering on 1 terabyte, we need to take, I need to wait till the time the query has run. I'll waste a lot of time. Just remember that we'll do clustering only on the tables which are greater than 1 terabyte. Okay, in order to save some time, I'm showing it on the 1 GB. So just I'll give some idea, but you can relate. So here, whenever I query, so see, when I do the select star, how many micro partitions it scanned? 68, right? So here you can see partitions are in total 68, partitions scanned is 68. That means 100 out of 100, right? 68. 68 partitions in total, 68 partitions it scanned. Okay. When I do the where class, then again it scanned all the partitions, right? If you see my query, where market segment is equal to building, it again scanned all the partitions. Okay. Maybe let me increase the table size. This is like very difficult to explain. Oh, large warehouse I'll use. So around 23 seconds, guys. 23 seconds. I'll go to history, refresh, 23 seconds almost. So total how many partitions are there? 666. For this particular table, I have around 666. When I do select star, how many partitions it scanned? It scanned all the 666. Okay. Now what I'll do is again I'll add one more where class. So how much time also I'll note down? Around 23 seconds. So now I will run along with one where class. Here the results are fast, guys, because of that warehouse level cache. Our results are little fast. Okay, anyhow, again it scanned how many partitions? 666 partitions. Again it scanned with where class. Where class again out of 666, it scanned all the 666. So what is this scanning? When I say scan, let's understand how the query processing will work in the backend. Micro partitions, if you understand, like, micro partitions, this is like one micro partition. And here to here, let's take this as a other micro partition, second micro partition. So each micro partition has one header file. Each and every micro partition has a header file. Here it will store range. I have it in PPT, so that's which holds the numeric data alphabetic maximum. So let's see if I have. Anyway, let me say, like, I'm not finding that. So here it has like this data for each and every column. It will maintain some data. What is the minimum in this case? 1, right? Minimum is 1. What is the max number? Max number is 10. Same way, what is the minimum? So in alpha, if it is alphabets also, I can find the minimum. Okay. And how many distinct records are there in this column? How many distinct? Everything, like all the 10 records are distinct. So it will put like 10. So this each and every file contains metadata. So this is like a header. This is called as a header. Each header file will maintain all this data. Okay. For example, male and how many distinct records are there? Here two distinct records. So it will put like male and female. Two distinct records are there. So this metadata file contains like metadata. What is the minimum value? What is the maximum value? What is the distinct value? It will maintain all this data in header file. Okay. Whenever I do a query, whenever like I submit my query, what will happen is till now whatever I covered, I'll change something now. The first step, my query will come to this optimizer. Optimizer will go to warehouse will become active. It'll, so till now what I said, it will download the data from data storage to this one, right? It won't do that. What it will do is, yes, optimizer query plan will receive, warehouse will so here now how many partitions we are seeing? 666, right? Total 666. That means here how many micro partitions are there? 666. It won't download the data from all these micro partitions. What it will do is it will download only the header files. It will download only the header files. Okay. So see, what is my query here? Building. In the where class, I have this building. Then what Snowflake will do is in the backend. So till 7, if it is one micro partition, it will download the header file. For example, if I say select star from employee where gender is equal to male, then what it will do is it will download. This all yellow color header partitions will go into the warehouse layer. Here the pruning will happen. The query pruning. What is pruning is the moment it receives the header file, it will check for that where condition. Okay. So that is called pruning. Where condition, it will check whether the so for example, guys, to make it simple, here let's assume that you have only male records. Here you have only female records. Here you have female records. My query is select star from employee where gender is equal to male. Then what first Snowflake is do? I'm saying like it won't download all this data. It won't download this data first. It won't touch even it won't even touch the data. It will download this yellow color header file, and here also one yellow color is there. It will download that yellow. Okay. Once it downloaded that yellow, the query pruning will happen. What is pruning is, okay, my condition is select star from male. Okay, male. It'll from on this header file, it will check whether the male record is there. Yes. Then it will shortlist this. Then it will go to the second partition. Again, it will check the male record is there. Here is there, right? It won't select this. Like this, it will scan all the micro partitions. So how many micro partitions the current query scanned? 666. That means it downloaded 666 header files to virtual warehouse layer. Then it will shortlist. For example, it shortlisted here this particular micro partition. Then what will happen? The query pruning happened, like 100 micro partitions were out of this, it shortlisted only 20. Then what Snowflake will do? Snowflake will download that 20 micro partition. It's shortlisted, right? Whatever it shortlisted, those 50, like let's say out of 100, it shortlisted 50. Then again, the shortlist is happened. Out of 100, it finalized 50. Then it will come to this layer and it download the entire micro partition. It will download the entire micro partition actual data this time, not header files. Understand? See, first header files will go. Header files, the query pruning will happen. Pruning means shortlisting the header files. So out of 100, if Snowflake shortlisted 50, the 50, whatever it's shortlisted, then it will move that entire data into virtual warehouse layer. Okay, first yellow color, this box will go. It will check for mail. Here the mail is there, so it will shortlist. Here it won't shortlist this. That is done. Shortlisting is happened. Once I finalized, then it will take entire data now. This entire data will move to the virtual warehouse layer. That is called query pruning. You can see pruning. That is what pruning. How many partitions in total? How many partitions it scanned? It is pruning. Now what I understand here, so the building data is there in all the 666 micro partitions. Usually in Oracle and all, if you don't have index in row optimized storages and all, if my query is 3, Oracle, if we don't added any index, it has to scan all 1 million rows. If you have 1 million rows, if this is the query, it will go come here, check like, is it equal to 3? No, no, yes, it will shortlist this one. No, 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 it has to scan all the data. But Snowflake is not even scanning the data first. It is getting the header files. To give you a quick example, see if my query is Boston, how many micro partitions? 1, total 6, right? Total 6 micro partitions are there. How many partitions it will shortlist now?
4.
How many?
4.
This one, we have
2,
second one,
3,
third one,
4.
fourth
Yes.
one.
Yes.
Total 4. But in our case, what our query is doing here, total 666 are there. It is going and touching like all the micro partitions, right? We don't want to do that, right? Again, I
Yeah.
don't want to scan all the data. So in that case, we need, what we have to do is we have to do the clustering inside Snowflake. Once we do clustering, this is what it will happen. All the Amsterdam records will be in 1 or 2 micro partitions, Boston 1. So earlier, like how many partitions we scanned? 4, but now 1, 2. That's it. Grouping the similar data or like same data into one partition. Okay. Now there is a concept called clustering depth. Clustering depth. So in this example, we have alphabets A to Z. A, B, C, D till Z. All the A to Z values are there in. So here in this we can see 5 micro partitions are there total. This bold color black line is passing. That's a query. So if that black line is passing through all the 5 micro partitions, then overlapping micro partitions are 5 and overlapping depth is 5. What is overlapping micro partition? In this micro partition, in this, in this, in this, in this. Then micro partitions are overlapping, right? Because my name is there in all the 5. When I do a query, it is scanning all the micro partitions. In second case, the number of overlapping micro partitions are 3 because A, B, C, D, E, F, I, J, H, I, J, K, L, M, N, O, P, Q, R, S, Z. These values are there in all these 3 micro partitions. K to Z are there are here, K to Z is here, K to Z is here. So that's why the number of overlapping micro partitions are 3 and overlapping depth is 3. In this case, I have the number of overlapping partitions 3, A, B, C, D, E, F, I, J, K, L, C, L is here and here also it is there. L, M, N, S, C here, Q, L, M, N, O, P. P is here and P is also here. But the number of overlapping micro partitions are 3, but this bold line is passing through these 2 micro partitions. That's why the overlapping depth is 2. So in the final one, A, B, C, D, E, F, I, J, K, L, M, N, O, P, Q, R, S, T, U, W, X, Y, Z. There is a no overlap. If you see, not even one value is not overlapping with other partition. So whenever the data inside micro partitions are not overlapping, then we can say the micro partitions reached the constant state, constant micro partitions. Constant micro partition means data inside one micro partition is not overlapping with other micro partitions. Then we can say our micro partitions are in constant state. In this case, right, overlapping depth is always 0 because I don't have any data overlapping, and overlapping depth is 1. Whenever you see overlap depth as a 1 and overlapping micro partitions 0, then you can see they are called constant micro partitions. This is also in certification they will ask. Number, see, ABCD is data, some random data as an example.
Okay.
That could be
Okay.
your name,
Let's
my name.
suppose.
Yeah. Called overlapping micro partitions, as simple as that. Okay. Now see, the data is like this: Boston, Boston, Boston. So we understand, like, I filtered using this building, but still it is scanning all the rows. So let's create one table. Create table customers. Look like as all right. So you can see I created one table. Okay. Let's query this table again now. Select star from customer 6. Right. I'm saying you will do clustering on tables greater than 1 terabyte.
Yes. It means your Snowflake sample data is more than 1 terabyte, right?
Yeah, there are 10 terabyte tables also. Okay. One developer will only do. So yeah, just 1 second. I'll come to that. We have like 10 or 15 minutes. So you can see total 710 micro partitions. So same table again I created, and we have around 710 micro partitions. Now what I'll do is I'll add this where class. Again I'll run the same query. This time also let me have to increase to large. So I have this where class. Again, it scanned all the 710 micro partitions. Even with our where condition, it scanned all 710. So let's see how we can improve the performance of this query. Okay, so the data is already there. I just need to cluster this table. Okay. Now I enabled clustering on this. I'm clustering by market segment. The idea is if we do clustering, then this is what my expectations. Before clustering, Boston is there 1, 2, 3, 4. But after clustering, this is how it looks like. So the data shuffling will happen. Whenever I initiated a clustering, all Amsterdam will go to one micro partition. All the Amsterdam will go here. Okay. All Boston will come to one micro partition. So the data shuffling will happen between micro partition from here to here, here to here, here to here. The data shuffling will happen. So Snowflake will charge us for this activity. So it takes time. Why I'm sitting idle is again like it takes some time to shuffle the data. See, it's all about even if you do order by, do you think like in the back end it will change? In your result you are ordering, in the back end no, it's not changing, right? Then why you like in
And
that case why you do indexing? Why you want to do indexing in Oracle? Yeah, but clustering also same thing, right? Physically the data is shuffling, right?
okay, it means they will store. Okay, I got it. Means physical level, it is changing in database itself,
Right.
right? Okay.
Yeah. Okay, now it's time. So let's run the now again let's run this with where condition. History, refresh the history, query ID. So guys, if you see after clustering, the number of partitions became 649. Out of 649, when I write this query, where market segment is equal to building, you can see it scanned only 129 micro partition, not all the micro partitions. It scanned only certain amount of like certain number of micro partitions, but not all. What is the advantage here? We are reducing the time. Instead of scanning all the micro partitions, we are scanning very few. See, these are statistics which I have taken. Yeah, you can see before right side is after clustering. This is like before clustering. This is before clustering. This is after clustering. Okay. So before clustering, this query took like 15 seconds. 15 seconds uh, to complete to scan all the 15,000 micro partitions. Once the data is clustered, okay. Once the data is clustered, see the time difference. Instead of scanning 15,000, how many it scanned? Only 28 it scanned. And if you see 15 seconds versus 1 second. So we can improve the performance of that query because what we are avoiding here unnecessarily the Snowflake has to scan all the 15,000 micro partitions, but here it will quickly scan only 28 so that you will get the result a little faster. So that's why we will do the clustering activity. And that too we'll do on the tables of 1 terabyte. Okay. Now selecting a clustering case, it's not as straightforward. We need to like research on this. It's not anything technical, but uh, the table I just closed. So if you have to do the clustering on this one, which one you will do?
Because gender
Gender,
is
right?
yes.
Each name will become like one cluster, or it has to like it will create like more clusters. It is like useless. And again, uh, one thing, alternately, what you can do if you want to avoid clustering, the best thing you can do is sort your data before loading. Sort your data before loading.
Okay.
Understand? Sort.
Yeah.
But what happens? Even if you
Yes.
sorted any DML activities, if I change this record to male to female, like, sorry, why I'm putting like my name, male, male to female, and again female to male. Any DML activities, if it's changed, then you need clustering. Otherwise, the best thing is just sort the data and load, as simple as that.
So actual record positioning will be changed, right, with the clustering? I mean,
Yeah, in the backend, the physical order of the data is changing. See, the high level idea is, is to avoid query scanning all the micro partitions. Hope you got idea, right? What is micro partitions? And the high level idea here is to avoid scanning all the micro partitions.
Yeah.
Yeah, if you have 1 petabyte of data, then 1 petabyte is divided anything between 50 to 500 MB. You'll have n number of micro partitions. There is no
Okay.
limit. Yeah. See, you are not creating a micro partitions. Once micro partition, you are reorganizing the data based upon the column that you need to understand. Yes.
Okay.
Selecting the clustering keys is again, it involves lot of research. See, if I don't know this data, like let's say you are like, I'm working with you, I'm a consultant for your team. I don't know your data. Simply, I cannot say like, okay, I'll create a clustering on email, or I'll cluster on gender. Don't know. What I need to is, I need to check with you what are the queries you are frequently writing on this table. Then I'll get some idea, like, which where classes, which columns you are using on where class, and which
very good.
columns you are using on joins, right? Then if I do a
Okay.
clustering, you will get benefit, because whenever you do a where conditioning, then my micro partitions are created as per your where class, so that you will get the faster results. So we need to, again, you need to do a clustering on the rows which are like largely distributed, not like uh, which are not less distributed.